Welcome to my YouTube channel. So here today we are going to be looking at elastic collision in 2D. So now elastic collision, the two conditions have to be met. We should have momentum is conserved. That's the first thing. Conserved, meaning to say whatever momentum you begin with, the initial momentum initial should be equal to the momentum final, which is momentum has got the symbol P. Initial momentum is equal to the summation of the final momentum. So if you add, now here we are dealing with 2D, meaning to say it's both in the x and the y direction. Therefore, we are going to be isolating momentum. We are going to be saying something like momentum in the x and the momentum in the y. We are going to understand this further as we look at questions. So we are going to be solving these three questions, and yeah, so basically those are the questions that we are going to be looking at. Then what we have is, so let's begin with this one. So momentum is conserved, and also the kinetic energy is also conserved. So from the kinetic energy is also conserved. We are going to be looking at how we are going to involve the kinetic energy in another video. So for this one, let's solve these. So to begin with, we have our first question, which says that a particle of mass 0.1 kg travels to the right along a frictionless surface with a speed of 2 meters per second, making a perfect elastic collision with a stationary particle of the same mass in such a way that the first particle glances off an angle of 37 degrees with the speed of v2 meters per second, while the struck particle moves at an angle of negative 53 degrees with the speed of v2 is equal to v2 meters per second. Find the speed small letter v2 and big letter v2. So how do you? So firstly, we are told that a particle of mass is traveling to the right with that makes a perfect elastic collision with a stationary particle of the same mass. So this means that mass 1 is equal to mass 2, like that. So we are going to just say momentum in the x. So the momentum in the x will be equal to, you know that momentum is a product of mass and velocity. So if you haven't watched the previous videos, kindly watch. So we have mass times the velocity. So in this case, we are going to say the momentum should be equal to, we have our m1 like that, v1 like that, plus our m2 v2 like that, should be equal to our m1. So we are saying that the summation of the initial momentum should be equal to the summation of the final momentum. So you add the two particles. So particle 1 is m1 times v1 plus m2 times v2. Then this side, m1 times v1 final, you can put this, plus our m2, which is our m2 v2 final, by putting that. So what are we going to have? So our mass number 1 is equal to mass number 2. Therefore, we are going to say this equation becomes m v1 plus m v2 should be equal to m v1 plus m v2, like that. So in this case, m is common, so we are going v divide our m throughout. When we do this, we are going to have v1 plus v2 should be equal to v1 cap plus our v2 like that. So we have something like this. We have something like this. So the only thing that we are going to add to this is x, everything. Let's just put x like that, so that we have x because that's momentum in the x, like that. So then v1 in the x, remember this one is the particle is traveling to the right, so it's moving like that with a speed of this, making an elastic collision. So we haven't been told whether it has an angle to begin with. So this one we are going to say that it's moving like that. So this is purely in the x. It makes the angle of 37 degrees. So if we are to draw this, when it collides, we have, when it collides like that, when it collides, we are going to have something like this. Then when it collides, so this is the case when it collides. So when it collides, it makes the angle of 37 degrees. Let me draw it properly here. So the two, when they collide, one goes up the angle of 37 degrees, the other one goes down at an angle of 50. This one, when it goes down, it makes an angle of 53. So if you add 53 plus 37, you're going to get 90 degrees. So if mostly if the particle m1 and m1, if m1 and m2 is equal to is the same mass, then the angle that they mostly make is 90 degrees. There is an exception if the question, specifically if the question says perfectly elastic. There are situations where the question does not say perfectly elastic, but you are calculating as if it's perfectly elastic. Then that one does not give you the same and the sum to be 90. But if they state to say perfectly elastic collision, just know that you expect the angle of 90 when you add them. So with that said, we have written our v1x plus our v2x should be equal to v1 cap x plus v1 v2 cap x, like that. So v1x is equal to 2 meters per second, remember, plus this one is stationary, it wasn't moving, so it's 0 meters per second, should be equal to v1. Then x is associated with a cosine, so we are going to say cosine of the angle 37 degrees. Remember the m1, this one goes at an angle of 37 degrees, so we are going to say 37 degrees plus v2 goes down. So remember it's saying negative 53, but we don't put negative, so it means it's below the positive x-axis here. So but in the calculation we are going to put it. So putting it in the calculation, we are going to say v2, then we are going to have the cosine of 53 degrees. So we are going to have 2 should be equal to v1 cosine of 37 degrees plus v2 cosine of 53 degrees, like that. After you are done in the x, you are going to say momentum in the y. So momentum in the y, you are going to have m1 v1 y plus m2 v2 y should be equal to m1 v1 cap y plus m2 v2 cap y, like that. So in this case m1 is equal to m2, so the equation becomes, we are going to use a common letter m, so we are going to have m v1y plus m v2y should be equal to m v1 cap y plus m v2 cap y, like that. So we divide our m throughout. This is going to give us a mass that is equivalent to v1y plus v2y should be equal to v1 y, like that, v2 cap y, like that. So we have So this is what we have. Did I put cosine of, not just cosine of 53, but don't forget the negative, very important. So the cosine of negative 53, very important. To give you 2 should be equal to v1 cos of 37 degrees. The cos of a negative and the cos of a positive, it's still the same, so it will just be v2 cosine of 53 degrees, like that. So replacing, remember this ball was moving purely in the x-axis, so its y value is 0, so we are going to say 0 plus 0 should be equal to v1. For the y, it will be sine of 37 degrees plus v2 sine of, the other one goes down, negative 53 degrees, which will be equal to 0 plus 0 is 0, should be equal to v1 sine of 37 degrees. The sign of a negative, the negative can be thrown out. We have v2 sine of 53 degrees, like that. So with that done, what are we going to do? So what we can do is we take this value this side so that it becomes positive. So we are going to have v2 sine of 53 degrees should be equal to v1 sine of 37 degrees, like that. So this is our equation 2. So in this case we have 2 equations. So having this one as our first equation, we are going to grab the equation. So when we grab our equation, what are we going to have? So when we grab our equation there, then let's make v1 the subject of the formula for this equation. So how do you do that? Just by your v2 sine of 53 degrees should be equal to v1 sine of 37 degrees. So to leave v1 alone, you are going to divide your sine of 37 over the sine of 37 degrees, so that we have v2 sine of 53 degrees over the sine of 37 degrees will be equal to v1, like that. Then the other thing that you are going to have is, if you do that, v1 is equal to this, you are going to get the value of v1 and replace it in this other equation, which is saying that we still have, you are still going to replace it in this equation, since you are saying that v1 is equal to that. So we are going to have 2 should be equal to v, where there is v1, which is here, you are going to replace what v1 is equal to. V1 is equal to v2 sine of 53 degrees over the sine of 37 degrees, which should be equal to, just that. Then we have plus our v2 cosine of 53 degrees. So with that done, so we replace there. So v1 is equal to this. So this is our v1. So we replace it like that. Then what else is there? We have the cos of 37. So we multiply this by the cos of 37. Okay. So we multiply by the cos of 37 degrees. So when we press on our calculator, to just be careful, we have the sine of 53 degrees divided by the sine of 37 degrees. It's giving me v2 times 1.327. Then we multiply times the cos of 37. Cos of 37 gives us a 0.8, like that. then we have plus V2 cos of 53 degrees. So this is going to give us 1.327 times 0.8. This is going to give us a value that is equivalent to 1.327 times 0.8. It's 1.0616 V2 plus the cosine of 53 gives us a value that is equivalent to 0.602 V2. So when we add these two, we are going to have plus our 1.0616. This is going to give us 1.663 V2 like that. Then when we divide our 1.663 divided by 1.663, our V2 will be equal to 2 divided by 1.663 will give us a value that is equivalent to 1.2 meters per second. So this is our V2. So V2 is equal to 1.2 meters per second. Then you are going to get this equation which says that V1 is equal to this, and replace the value of V2 to find what V1 is equal to. So we are going to get this and put the value of V2 to get V1, because it's saying that V1 is equal to V2 sine of 53 degrees over the sine of 37 degrees. So this gives us our V2 is equal to 1.2 times the sine of 53 degrees over the sine of 37 degrees, which will give us 1.2 times the sine of 53 divided by the sine of 37. This gives us a value that is equivalent to 1.333. When we multiply this, 1.2 times 1.33, this is going to give us a value that is equivalent to 1.596 meters per second, which can be written as V1 to be equal to 1.6 if rounded off like that. So this is our V1 like that. Let's look at our next question. So we have a gas molecule having a speed of 300 meters per second horizontally collides elastically with another molecule of the same mass which is initially at rest. After the collision, the first molecule moves at an angle of 30 degrees to its initial direction. Find the speed of each molecule after the collision and the direction of the second molecule. So we have one molecule here, another one, then they collide. So remember, we have thought of the same molecule, meaning to say they have the same mass. Therefore, if they collide after the collision, so they collide elastically, meaning to say their separating angle is equal to 90 degrees. So that means to say if one goes 30 degrees up there, 30 degrees, one goes 30 degrees, then that means to say the second one should go at an angle of 60 degrees. That's the meaning. 30 plus 60 will give you 90 degrees. So that means to say, since it's below, the angle for this one is negative 60 degrees. But for the diagram, we are not going to have the negative. But in our calculation, we are going to use them. So we are going to say momentum in the x should be equal to m1 v1x plus m2 v2x should be equal to m1 v1 cap x plus m2 v2 cap x, like that. So our m1 is equal to m2, which should be equal to m. So we are just doing the same. So it will be m v1x plus m v2x should be equal to m v1 cap x plus m v2 cap x, like that. So we divide our m, we divide our m, we divide our m, we divide our m. So the value here will be equal to v1x plus v2x should be equal to v1x plus our v2x, like that. So we are going to get our value that is equivalent to, let's replace. For the first one, it was moving horizontally 300 meters per second. So that means to say it was purely in the x. So the first one was moving, the second one was not moving. So we are going to say this v1x, it will be 300 plus v2x will be 0 because it wasn't moving. Should be equal to v1x is v1 cosine of 30 degrees. Remember, it went up, plus the v2 cosine of the angle 60. Now in this case it will be negative 60 degrees, like that. So we have 300 should be equal to v1, this is only true if the mass is the same, v1 cos of 30. Let's calculate this. The cos of 30 degrees gives us 0.88. So we are going to have v1 times the 0.866. Then we have plus our v2. Then we are going to have the cos of negative 60 is still positive, even if you try to verify. So it is 0.5. So we are going to have 0.5 v2, like that. So we have 300 should be equal to 0.866 v1 plus 0.5 v2, like that. We are going to go now to our momentum in the y. So the momentum in the y should be equal to, we have m1 v1y plus m2 v2y should be equal to m1 v1 cap y plus m2 v2 cap y, like that. So remember, the first ball was just moving in the x, so meaning to say the initial is 0 here plus 0, which will be equal to, what is our m1? Remember, m1 is equal to m2, which is equal to m. So we are going to put m v1 cap y plus m v2 cap y, like that. So with this, we are going to get our 0. In fact, so we have 0 should be equal to m v1 cap y plus m v2 cap y. Then we divide by m, we divide by m, we divide by m, we divide by m to get rid of the m. We are going to have 0 should be equal to v1 cap y plus v2 cap y, like that. Remembering the angles, we have 0 should be equal to the y, it will be v1. Remember, it went 30, so we have the sine of 30. Then we have plus v2, then we have the sine of negative 60 degrees, like that. So we have the sine of 30 will give us a 0.5, so we are going to say 0.5, like that. Then say v1, because sine 30 is 0.5. Then we have, obviously it's going to give us minus the sine of negative 60 will give you a negative value, which will be negative 0.866, like that, v2, like that. So this is our value. Taking this value this side, it will be 0.866 v2 should be equal to 0.5 v1, like that. We divide our 0.866 0.5 866. This is going to give us our V2 should be equal to, if we divide our 0.5 divided by 0.866, this is going to give us a value of a 0.577 V1. So this is our V2 will be equal to 0.577 V1. Getting the other equation, which was this equation, and replacing, what do we get? So getting this equation, we have said that V2 is equal to this. So wherever you see V2, you replace with that. So we are going to have 300 should be equal to 0.866 V1 plus 0.5. V2 is 0.577 V1, like that. So that this gives us a value that is equivalent to, we have a 300 like that. Then we have a 0.866 V1 plus we have 0.5 by 0.5 times 0.577. This gives us a value equivalent to 0.2885 V1. Then we add our 0.2885 plus 0.866 gives us a 1.1545 V1. We have 300 there. Then when we divide our 1.1545, we divide our 1.1545, our V1 will be equal to, so 300 divided by 1.1545, we are going to get a 259.85 meters per second. Remember, we have said that V1 is equal to this, so we are going to get the equation. Getting this equation, we are going to have our V2 is equal to that, so we replace V2 is equal to 0.577 times V1, which is 259.85, which we have found. So multiplying this, we are going to get times 259.85 times 0.577. This gives us a value that is equivalent to 149.9, like that. So this will be our value of V2 meters per second. Our last question. So we have a billiard ball moving at 5 meters per second strikes a stationary ball of the same mass. So after the collision, the first ball moves 4.33 at an angle of 30 degrees with respect to the original line of the motion. Assume an elastic collision, ignoring friction and rotational motion. Finds the struck ball's velocity. So we are going to do the same. So we have two balls that have struck each other like that. So it's elastic, meaning to say if this is 30, this will be negative 60, like that. So we are going to just say momentum in the x. So knowing that m1 is equal to m2, which is equal to m, we are going to say m v1 x plus m v2 x should be equal to m v1 cap x plus m v2 cap x. 1, so this m will be cancelled throughout, so that we have v1x plus v2x should be equal to v1x plus v2 cap x. So our v1x, in this case, it was moving at 5 meters per second, so we can say 5 meters per second. So this one was moving purely in the x, moving 5 meters. They haven't given us the angle, so purely in the x plus our v2, it was stationary, so it will be 0 meters per second, should be equal to the v1 cap. So we have the v1 cap, then it will be attached with a cosine of 30 degrees. It went 30 degrees up, plus the v2 cap cosine of negative 60 degrees. So this gives us 5 meters per second should be equal to v1 cap cos of 30 degrees. Negative cos will tend to positive still. V2 cap cos of 60 degrees. This gives us a value of, we have 5 should be equal to, we have the cosine of 30 degrees, which should be equal to, we have 0.866 v1 cap plus our v2 will be equal to the cosine of 60, which is equal to half. So we are going to say 0.5 v2 cap, like that. Now let's analyze the question. What have we been told? They have told us that after the collision, the first ball moves at 4.33 meters per second at an angle of 30. They have given us everything. All they want is finds the struck ball's velocity. So we are going to replace 5 should be equal to 0.866. The one that was moving moves at 4.33, like that, plus 0.5 v2 we don't know. So we have 5 should be equal to our 4.33 times our 0.866. This gives us a value of 3.749978 plus 0.5 v2 cap, like that. So we have 5 should be equal to 5. When this comes this side, it will be minus 3.74978 should be equal to 0.5 v2 cap, like that. So if we subtract our 5 minus this value, it will give us 1.2502, which should be equal to 0.5 v2 cap. When we divide our 0.5, we divide our 0.5. This is going to give us a value of v2 should be equal to, divided by 0.5, it will give us a 2.5 meters per second. So this is the answer that was required. Okay, let's look at the last question. Though that was supposed to be our last question, we have a ball is moving at 10 meters per second and strikes a ball initially at rest of the same mass. Upon impact, the first ball begins to move with a velocity of 6.2 meters per second at an angle of 30 degrees. At what angle and the velocity does ball 2 move? So if we were provided with perfectly elastic, we expect it to be 60 degrees, but if we are not given, there is a chance that it might be something that is not even 60. So let's try out this one. So we have momentum in the x. We are going to say our m v1 x plus m v2. Remember, m1 is equal to m2. According to this, we have the same mass, should be equal to m v1 cap x plus m v2 cap x, like that. So we can cancel out the m throughout, so that we have m1 x plus our v2 x should be equal to v1 cap x plus our v2 cap x, like that. So our v1 x is equivalent to, what do we have for v1? So it was moving at 10 meters per second, so we are going to put the 10 meters per second there. Then plus this one was at rest, so it will be 0 meters per second should be equal to v1. Then it starts to move at 6.2 meters per second after impact, according to what we are told. So it will be our v1x, we say v1 cosine of the 30 degrees plus our V2 cosine of our angle. In this case, we are going to call this angle like that. So that will be our angle. This one was theta, then this one will use that. So we have 10 meters per second should be equal to V1 cap cosine of the 30 degrees plus we have our V2, not V squared, V2 cap cosine of the unknown angle. So we have 10 should be equal to our V1, our cos of 30 will give us, a 0.866 V1 cap plus our V2 cos of this. So this gives us, we have the 10 there. Then we are done with everything that we can do to this equation. Oh, not forgetting V1, they have told us that it starts to move at 6.2 meters per second. So let's put that. So we have our 10 should be equal to 0.866 times our 6.2. Then we have plus our V2 cap cos of this angle. Then when we multiply 0.866 times 6.2, this gives us a value of 5.3692 plus our V2 cap cosine of this angle. So we have 10 minus 5.3692 should be equal to V2 cap cos over this angle. So our 10 minus this value, this will give us a 4.6308 should be equal to V2 cap cosine of this angle. So this will be our equation 1. We have dealt with momentum in the x. Let's deal with momentum in the y. Remember, so we have mv1y plus mv2y should be equal to mv1 cap y plus mv2 cap y, which will be equal to, remember it was moving purely in the x-axis, so we have 0 plus 0 should be equal to, the initials are 0, should be equal to our mv1 cap y plus mv2 cap y, like that. So we have 0 should be equal to mv1 cap y plus mv2 cap y like that. So we divide our m throughout so that we have our 0 should be equal to v1 cap y plus our v2 cap y, like that. Knowing that our v1 was equal to, we are told that it moves at 6.2, so we are going to say 6.2. The y component is associated with the sine of the angle, which was the 30 degrees. Then we have plus our v2 will be v2 cap sine of the unknown angle, like that. So this will go this side, it will be negative 6.2 sine of 30 degrees, which should be equal to v2 cap sine of this angle. So the 6.2 sine of 30 degrees gives us a value that is equivalent to negative 3.1, which should be equal to v2 cap of the sine of theta. So as you can see, we are now going to solve the equations simultaneously. So we are going to say simultaneously. So simultaneously, we are going to get this equation 4.6308 should be equal to, what do we have? We have v2 cap cosine of this angle, we also have another one which is our negative 3.1, this equation 3.1, which should be equal to V2 cap sine of the angle theta, like that. So how do we solve? Make sure that sine is on top. So this equation, let's say I call it my 1, this one I call it my 2. So you are going to divide equation 2 divided by equation 1, which will be negative 3.1 should be equal to V2 cap sine of our theta divided by our equation 1, which is 4.6308, which should be equal to, we have our V2, where is it, V2 cap, this one is having the cos of this angle. So as we divide, this one and this one cancel. 3.1 divided by our 4.6308, this gives us a value of 0.669, which should be equal to sine of this angle divided by the cos of this angle. We are going to have the tan of this angle, which will be 0.669. Taking the, so it is negative because there was a negative there. Taking the tan inverse of 0.669 degrees, leaving the angle there, it will be, the angle will be equal to, the tan inverse of this answer will give us a negative 33.8 degrees, like that. So that is the angle. So it means to say one particle went up like that with an angle of 30 degrees, then this other one went down with an angle of 33.8 degrees, like that. So that's how come we have the negative. Finally, to find the velocity, get any of the two equations. Let's get the negative so that we see something. We are going to have our 3.1 should be equal to V2, which we don't know, sine of the angle negative 33.8 degrees. This sine of a negative, it will be negative, so it will be negative V2 sine of 33.8 degrees, negative 3.1. Then we divide over the negative sine of 33.8 degrees over the negative sine of 33.8 degrees, so that we have our V2 should be equal to our 3.1 divided by our sine of 33.8. This gives us a value that is equivalent to positive 5.573 meters per second. So that is how we solve that one. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.